Okay, let's try problem 4.66. The fastest pitched baseball is clocked at 46 meters per second. If the pitcher exerted his force, assumed to be horizontal and constant, over a distance of 1 meter, and a baseball has a mass of 145 grams, A, draw a free body diagram of the ball during the pitch. Okay, so I'm just going to do this over here. So I'm just going to draw, let's do a straight line. One more try. Let's draw my X and Y axis over here. Change colors. And so the only force on this ball is going to be the force from the pitcher's hand. So we'll call it F sub hand. And so that's the only force that we're worried about here, just the force from the hand. So that's part A. So let's go and try part B. What force did the pitcher exert on the ball during this record-setting pitch? Okay, so before we do this, let's write down some of these variables that we know. So we know that the final speed was going to be 46 meters per second, right? V sub F is equal to 45 meters per second. And we know that he exerted it over 1 meter, so we'll call this F sub F is going to be 1 meter. And we know that the baseball has a mass of 145 grams, so M is going to be equal to 145 grams. Okay. And another thing that we know from this problem is that the initial velocity, right? We know that this ball had to start from rest. So V initial is going to be equal to 0 meters per second. So one of the equations that we learned from last chapter was an equation that related velocity and distance. So let's pull that one out. So Vf squared, the final velocity, is going to be equal to the initial velocity squared plus 2 times the acceleration times the distance. Okay, so the first thing, so we want to know the force. So before we find the force, we need to find this acceleration right here. So let's go ahead and solve for that because we know all the other variables, right? We know Vi is going to be 0, so this is going to go away. So this just becomes Vf squared is going to be equal to 2 times the acceleration times the distance. And so solving for the acceleration is equal to Vf squared, the final velocity, over 2 times x. And we know x, it's 1 meter, and we know the final velocity is 45 meters per second squared. So let's just plug these in. 45 meters per second, and this whole thing is squared, over 2 times 1 meter. And when you plug this into your calculator, you get 1060 meters per second squared. Okay, so that's the acceleration that the ball underwent in the pitcher's hand. So to find the force, right, we know that force is equal to mass times the acceleration. And we know the mass of the ball, 145 grams. But let's convert that to kilograms just so we're consistent here. So 145 grams, right, if I'm convert to kilograms, is going to be equal to 0.145 kilograms. So the mass is 1.145 kilograms. And the acceleration is going to be 1060 meters per second squared. And then when you plug this into your calculator, you get 150 kilogram meter per second squared, which is just equal to 150 newtons. Okay, so that's the answer for part B. What force did the pitcher exert on the ball during his record-setting pitch? He exerted 150 newtons. Okay, so let's try part C now. Estimate the force in part B as a fraction of the pitcher's weight. So an average male weight is just 75 kilograms. So let's say he weighs 75 kilograms. So to find the weight, right, that's a force. Weight is a force. So the mass of the pitcher is 75 kilograms. So we'll call that M. And so to find the weight, we'll call it force of weight. It's going to be 75 kilograms times the force of gravity. which is 9.8 meters per second squared. And so when you put this in your calculator, you get 735.0 newtons. Okay, so now to find but that's not what we want to know. We want to know the fraction of the pitcher's weight. So to do that, all we have to do is 150 newtons over 735 newtons. And this comes out to 0.20, or 1/5. So 1/5 is the fraction of the force that the pitcher puts on the ball when compared to his weight. And that's problem 4.66.